So first of all, rational expressions are fractional things that we can write with polynomials usually in the top and the bottom. Now if you take a look at some of these, 1 over x, x plus 2 over x minus 3, x squared minus 5 over 3x, they're all different kinds of fractional relationships that are written, and they have some kind of expression either on the top or the bottom. Our job is, just like with fractions, they want us to be able to reduce if we can. So that's going to be where part of our focus is going to be today. So let's take a look at the first example. In a problem like this, if they want us to simplify this, we're going to look for a common factor. Now if I look in this top, I can see that a 6 would go into both of those. So if I was to rewrite this, if I divide this one by 6, I'll be left with x. This divided by 6 would be 2. Once that happens, I can now see that the top and the bottom have a matching piece. So these two can cancel, and I'll be left with 6 as my answer. So again, our job is to try to reduce as much as we can. Let's take a look at the next one. So on this one, most people have no problem with the 15 and the 25 part when they're simplifying, because they'll think, okay, 5 goes into both of those. So 5 will go into 15 3 times, and 5 will go into 25 5 times. Now this is where some people have a problem. If there's a b squared there, you can almost imagine that there are two b's down here, which means that I have a pair of them that will cancel. So I'm left with a 3 in the top, and I'm left with 5b on the bottom. Now in this one, I can see on the bottom that there's a 3 that I could pull out, which means if I divide this by 3, I'll be left with c. This divided by 3 would be 2. And then I have 12c squared. Now there isn't a big piece with the c's that can reduce, but at least the 3 and the 12 can. So 3 will go into itself once, and will go into 12 4 times. So if I was going to reduce this, it would be 4c squared over c plus 2. Remember, our job again is to go through and reduce as much as we can. Okay, now on examples like this, as soon as I start to see x squared, I know that I'm going to have to probably factor. But on the top, you can see there's a 2 in common. So if I pull a 2 out, 2x divided by 2 would be x. 12 divided by 2 would be 6. Now if I look down here, I also know that I can factor this into x minus 6 and x minus 1. Now I can see these two match, so I'll be left with 2 over x minus 1. Okay, last one. This one I can see that there's a 5 in common on the top. So if I pull the 5 out, I'm going to be left with x minus 3. Now this problem is sometimes referred to as an opposite problem, because you'll notice on the bottom that those are written opposite of what we normally would see. Normally I would see the x squared first and the 9 second. The main issue with this though is that the x squared happens to be negative, and we don't usually deal with things that are negative. So the first thing that I would do is pull a negative 1 out. That basically means I would change the signs of these two. So it would become x squared minus 9. Now once it's in that form, I can actually factor this part. So I'm going to rewrite the top again, just the way it is. Leave the negative 1 out here. But I know on the bottom, this x squared minus 9 can be factored into x plus 3 and x minus 3. Now these two pieces will cancel, which means that on the top I'm going to be left with 5. On the one I'm going to be left with negative 1 times x plus 3. Now some people, once it's done, may actually distribute that negative 1 on the bottom, or it might look like this. So either one of these would be acceptable ways to see the answer.